Hi, my name is JULIO VIERA. Today I'm working with the QEMU PCs. I'm making one a router and the other one will be a PC. So I just make a little topology using two switches, two computers, and a loopback connecting to the second switch that gives internet to one of the computers that will be the router. Let's check the topology right now. Well, right now here, this is the computer. The PC4 will be our computer in the network. The computer is part of the 10000 network. This is the other PC, a QEMU PC, right here, connecting to a switch. And as you can see, we have a second switch connected. And this will be going here to a loopback. That is a loopback address that gives us real internet via the loopback. Okay, so the topology looks like this. Right now, neither this PC, neither this are routers, or neither this PC that we will be working on is a router. This is just a PC. What we will do and what we want to accomplish is to make the R1 a router. So let's begin with the video. Welcome to a GNS3 exercise lab. Here we make two QEMU PCs. One of them will be the router and the other will be the PC. So we will be using two PCs, two switches, one loopback that we will use to go to the internet. So we are changing the host name of one of the QEMU PCs to R1 and the other will be the PC on the network, that it will be the PC4. Now we are connecting the loopback address to get connectivity to the internet, and it will give IP address to the router. That will be the 192.168.137 network. So this will help to that computer to get the internet in the ETH0 network. Then we are creating right now our virtual office topology that we are working on. Remember, the scope here is to make the PC with the host name R1 to act like a router. For accomplish that, we have to make that computer to route and forward the IP address. Right now we are running this scenario. We are working with the router. This is our very easy steps. We will be first creating root privilege, then we will be creating the LAN IP address in Ethernet. We will be creating in the Ethernet ETH1 the IP address of the network, that is the 10.0.0.1. And right now this computer needs to be that all the IP tables to be flushed. We will be doing that. Also we will check it out that the ETH0 right now has an IP address that was given by the loopback address that is acting like a DHCP server. So let's see right now how this is working. Let's check it out. As you see, we have the 192.168.137 192.168.137.25 IP address given by the loopback address with the CIDR 24 network. Our gateway of last resort is the 192.168.137.1. That is the loopback address. Now we are taking the root privilege. Now let's create the IP address for the ETH1. That is the 10.0.0.1 netmask 255.255.255.0. Here is no need to create a gateway for this LAN because this is a router. So we will go to delete the IP table in 4 commands. These are the commands. So IP table flush, IP table delete chain, IP table net flush, IP table net delete change. And as you see, we got the IP table flush and we have the default IP table. Now we will create, we want to mask our LAN network, that is the 10.0.0.0 network. When it passes to the ETH0 network, that will be our public IP address. Our public IP address will be the 192.168.137.25. That is the IP address that the interface ETH0 has. Okay. So now we are doing the post routing and masquerading and telling that the ETH0 is the outside. This is like creating the NAT in a PC. And then we will create a forward telling who the inside network, that is the ETH1, that will pass into the ETH2. As you see now, this is how the IP tables will look like. Now we are doing the forward with the echo 1 command, and let's test this router. Right now we will go to the PC. In this PC we need root privilege as is the same. It's very important to have root privilege because there is some commands that the sudo command do not support. So to begin with, we will put an IP address to the ETH0. That will be the 10.0.0.2 in that computer. And then when we create this IP address that we are creating right now, we will add a route. Our route will be the 10.0.0.1, that is the interface, the LAN interface on the router. We will check the route. Here is. Now we are checking that we can ping the gateway. We got the ping, so we are okay right now. Now there is a very important thing we have to do. Okay, I know we got internet, but we need a DNS server for resolution of the fully qualified domain servers like Google. Here is the ping. This is the 8.8.8.8 is a Google DNS server that we'll be using. So we will move to in Linux to the etc, as you see, folder. There we'll create this command with a name, server name, with the IP address, and you see that now we can ns lookup Google, we can ns lookup Yahoo, and we can ns lookup Facebook, and give us the correct information about all the networks of Yahoo, of Google, and Facebook. So this means that the R1 is already working, that is masking our IP address, and now we are making a trace route to go to the 42.2.2. That is another DNS server we have that is very cool, and we will check how many hops of distance we are. That server is about 11 hops of distance from our computer. Right now, we are kind of changing the symbol of R1 because it's a router. I hope this will be informative for you, and thank you for watching. Thanks.